Okay. So
Sorry
today
for
we will,
disturbing.
yeah, please. Tell me, sir.
Nothing I said. Sorry for disturbing.
No, no issues, no issues. Thanks for remembering me that actually. I forgot to switch on the time recording. Okay.
Hmm.
Moving on here, actually, the problem today that we are going to see is like we are going to see the stability of the road embankment and how the construction process of the embankment it looks to be. And after that, I'm going to validate it actually. So if you just look into this particular problem, actually, don't be get confused or don't be weird of this. It's very simple, easy process. What I'm going to do for your better convenience, I'll explain you first, and again I'll delete all these particular steps, and I will do it in front of you actually. Okay. But for the time being, you just remember this. Initially, I have only the soil layers, and then actually first layer of embankment I have constructed. And then if you see here, this is where the consolidation analysis, the symbol, it will tell you that. So this symbol is consolidation. If it is a plastic analysis, this is the symbol. And if it is a consolidation analysis, this is the symbol. Okay, they will show you if you are writing a Plaxis certification exam, they'll show you these particular symbols and they will ask you what is that. Okay, so you should be in a position to answer this. If it is this one, either it is a KO procedure or gravity loading, they'll ask you. It is a KO procedure. If the gravity loading position is something, it is like this. Okay, so you should be in a position to tell by looking into these particular things. Okay. Initial phase KO procedure I have selected. I'm doing the first level of embankment, and then I'm doing the consolidation after backfilling the soil over there in that particular slope. I'm doing some consolidation analysis. After the consolidation, I'll go for the second embankment, which I have just constructed the second embankment. After the second embankment, I will do the consolidation analysis again. So the consolidation here, you see this, guys. So the first consolidation phase, actually, this is the consolidation analysis. And this represents that groundwater level conditions and ignore, there is no thermal considerations at all, actually. And if you see this one, this is the stage constructions, and this is where actually the symbol it is changing. So when you just go for this, this is where like a minimum excess core pressure conditions they have selected. Previously, it was like a stage construction. If you see the symbol like this, it's a stage construction. If you see the symbol like this, it's a minimum excess core pressure. Now, I'm educating you. Try to watch the symbols also. Try to watch the symbols. This will be helpful for you. Okay, so just giving okay. Now you will come to know this is a KO procedure, this is a stage construction, this is a groundwater level by ignoring the thermal activities and all. What happened, suppose if the same symbol of an end conditions, I didn't ignore the temperature, I just considered this as an earth gradient. See this? It's changing into red color. Now use the temperature previous steps. So now see this one, this symbol it is going it over here. Okay, so follow this. Core pressure calculation types is like this is not applicable for this particular problem. That's why it has been selected. Okay. Now this is first what I did. I did my soil parameters, everything, and then I backfilled my soil, and then I did a consolidation analysis. After this, again, I built another backfilling of that. The second stage of backfilling I have done. And again, I performed the consolidation analysis just to know like by condition keeping that a minimum excess core pressure conditions. But here in the stage constructions that when I'm going, first level of a consolidation, when I'm going for the stage construction, I'm giving a time interval. I'm forcing to do the consolidation for 30 days, whatever it may be. I'm forcing to do that consolidation for 30 days. But when I'm going for the second level of a construction, I'm not forcing it actually. I'm just leaving it into the nature, make it whenever in how many days it will come to the minimum pore pressure conditions, that is 1 atmospheric pressure. When it will come, in that particular time, I'm going to consider as the end of consolidation. Next, actually, for this particular slope, I'm doing a factor of safety analysis. Okay, And if you select this particular one, so this particular one, second embankment, before the consolidation, they were doing the factor of safety analysis. And if you consider this one, when the stage one of construction, it is a happened date, and then they were doing the consolidation. If you consider this particular one, so when the phase one backfilling is there, then they are doing it. So when the phase one consolidation is there. Okay, to make you comfortable till this, actually, how I can tell you is like, you can just see this one. I have an empty site. After the empty site, I backfill the material. After backfilling the material, immediately I just identified what is the factor of safety for this. Because after backfilling, if my slope or due to the self weight, actually, if the slope itself is self failing it, then there is no point of going for consolidation actually. So I just wanted to know whether the factor of safety for that it is meeting or not. Next is like going for consolidation. After consolidation, the strength has been increased maybe. So in that particular point of time, what is the factor of safety I'm identifying it. Next, again, I'm backfilling it. Over the stage one, if I fill the backfill of the second stage, then in this particular case, what is the factor of safety I'm identifying it. Next, again, I'm going for the final consolidation. And after the final consolidation, again, I'm doing the factor of safety analysis. Now, I think from this particular point to this particular point, what we are doing, you got a clear idea?
Yeah.
Okay, fine. So nothing, it's simple. Construction, empty land area. We are bringing the first backfilling layer. We are bringing, we were doing the consolidation for that. We were bringing the second layer. We were doing the consolidation for this. For an each phase, actually, we were doing the factor of safety as well. This we have done without the drains. And there is another repeated process that we have done that is with the drains actually. So with the drains that we have done for that particular process. That's it. So for visualization, maybe you have seen that is a very huge number of tasks that they are performing it here. No, that's very simple and very easy to as well. Only for aesthetic looking, look wise, it is very difficult. But when you just understand the concepts, it's very simple, very simple. Okay. So the next is like, if I just go for the drains, now you see this, the drains are also activated here. Now, actually, the thing, how you activate the drains is like, when you just go over here, you have a drains option here. You have to activate this drains. So how do you create a drain? This is what you guys don't know. Now I will teach you that. So when you just go for the structures, in Plaxis, there is a direct option to create a drains, which doesn't need any kind of a material properties, nothing. Entirely depends upon the soil surrounding material properties. Your software is going to calculate that particular part actually. So that's where actually you can see this. I'm sorry. This is where like create a drains. Okay. So under the line, if you just go here, you can see this. There is a thing called as a create a drain. Okay, this is where how you can able to create these particular drains. After creating one particular drain, you know how to use the array options. We already used it in the first classes. We have learned this. So using the array option that they have selected it. So in X direction, number of columns is like how many you want? 1, 2, 3, 4, 5, 6, 7, 8, 9, including the master one is 10. So you just keep it as 10. Distance between each one is like 1 meter or 2 meters that you are giving it. That's it. Okay. It's a rectangular pattern that we were just going. We were just going for this.
Sir, where is the input for depth?
Sorry?
Sir, it is starting from the bottom of the embankment. It is going to the sand layer. How you have decided the depth, sir?
See, it is a randomly selected one over here actually, but that depends upon the site to site. You can decide and then you can go ahead.
No, you have drawn a line and then activated the drain, or what exactly? Then it will take automatically the same layers. in sequence, one after the other in 10. Sir, have you understood my question?
Hello.
Hello.
Hey, sorry, there was a network glitch at my side. Okay. Moving on. Yeah. See, if you draw a line, you can just select, draw a line. After that, you
That
can
is what
right
I'm
click here,
asking. Okay.
create.
Okay.
You can
Okay.
go and click on drain. This is one way.
That is what I was asking.
The other way is like directly you can just go in the line itself, directly you can go create a drain and then you can create it. This is also one more procedure. Okay.
Fine. Thank you
But
so
the
much.
drain, yeah, but the drain, it doesn't need any kind of a material properties.
No, you told already.
Yeah.
Thank you so much.
Yeah. Okay, fine. So this is how actually I've done. So coming on to the soils that I've done, I've just collected the borehole material properties, peat, clay, and sand. And if you would like to study this, this is a clay. I've just considered it as a soft soil under A behavior. So where I just use this lambda and kappa values, and for the strength, cohesion, friction angle, and dilatancy angles. Okay, so these are the few things that I've used it here. And next is for the embankment. Embankment is a hardening soil with a drained model that I've selected it. Okay, so backfilling material, you should never choose it as an undrained A conditions because it will calculate the pore pressures above that ground level, and it is not good for the backfilling materials. We should not calculate that. But maybe during your practice sessions, try to change it to an undrained A behavior and see what is happening to the slopes. Okay, and then it's a peat material. So these are all like maybe the submerged conditions are also water content may be there. So I'm calculating the pore pressures. So that's why I'm going with an undrained A conditions. Next is like a sand. Actually, again, I'm doing it. And this is like at the very bottom. If you see to the image too as well, the sand, the green one actually, this is the green color and this is the green color actually. If you see this thing, this color is at the bottom, which is the drain conditions I'm taking it. Now see this, guys. Observe the material properties and change it very cleverly when we are playing up this. So my drains are coming over here where this region and this region is occupied, and these two regions I'm calling the material properties with undrained A conditions. Undrained A conditions. And if my this particular material property is also an undrained A conditions that which are having a huge amount of a water content and need to be calculated in that particular cases, better I can consider this. But in my particular problem, structural element is not touching to that particular layer, so that being it as a drained is also fine for me. So when you are extending the depth of a drain, make sure that the material properties are also supporting for you. It's not blindly that you can go for the depth. You just make sure that really it is needed to be modeled as a drained or an undrained A conditions. You can choose this. Anyways, the backfilling is a hardening soil which doesn't need an undrained A conditions. It's not a short term; it's all like a long term analysis, so that it requires drain conditions only. Okay, so make sure that, and this just went for this. So for the structures, if you see this one, to create this actually soil polygon they have been selected. So create a soil polygon, and where the soil polygon you can just create it something like that. That's it. How you build this, and the same way here you can able to build this. And if you would like to cut this particular things also, you have something called as a cut polygon. You can cut it over there. So that what happens, this you can assign one different material, This you can assign one different material, or during the construction also you can able to reduce it. Here it's like a 4 meters of a height, which I cannot able to build at a time. So that's why I went with the two different layers here. Okay, moving on, meshing. As I have done some small changes over there, that's why it is asking you to regenerate the mesh list actually. So generate the mesh. And you guys know what's the meaning of like green over here. So the mesh is also got created. Now moving on to the flow conditions and to the stage constructions actually. Yeah. Now I just came up to like this. Let's try to calculate it. It may throw some errors. Okay. Select the nodes that stress at the points and do not remind it. And okay, these are all like a warnings only. So ignore the feedback and you can start calculating it. So it will calculate you the results actually. Okay, fine. Anyways, just before going into the results, I would like to make you comfortable over here too as well. Oh my God, it is like stop calculating the figures. Okay, so what I can do, I can just so here actually you can't select the multiple phases and then you can able to delete it because this is one of the construction process. So deleting at a time would be like very rare where you can see deleting all the things at a time actually. So suggested thing is like that's why they have given it as like a one part only that you were able to delete it. And even though if the option available too as well, so I suggest that in any of the software too as well. So don't delete all the steps at a time. Try to delete step by step. Though if it is like a 50, 100 or 150 steps also, whichever the steps that it is affecting to the other steps and all, that we will just come to know if we do like this. And what's happening in the image also, you can able to see this. This is my first case. So first I just added a thing. So to the phase one, I'm just naming as a stage one construction. So I'm just doing the stage one construction. So just give plastic calculations. This is okay. Now this is the activate this particular thing. After this, you can go to the another phase. Now in this particular phase, you can say this like stage one consolidation. So now here you can just go for the consolidation analysis. And then now actually you can see this consolidations for how many days I was making to for the stage construction. Time interval is of like 30 days. I'm forcing here to do it for 30 days. Next is like I'm just going for this. Now you can say this one. This is my stage two construction. So the stage two constructions again with the plastic calculations. Now you can activate this one. So now you add one more thing. Now here you can say this stage two consolidation. So now you can choose this as a consolidation over here. Now you can decide this, the consolidation as my construction is completely processed, right? So instead of a loading type, I can just choose it as a minimum excess core pressure conditions and where it will reach just over 1 kilonewton per meter square, it will stop. So that's where the stage 2 that I've done it. Okay. Now, let's say calculate this particular thing. Let's see. I'm just calculating up to this. Wow. Soil body seems to be a collapse. That's interesting now. Color is an embankment material properties itself. Soil body seems to be collapse. So soil body strength that is not sufficient. Okay. This 0.858688 up to 0.88 it is going, and then it is failing it over there actually. Okay, let me go back here to the meshes. Let me go do fine mesh. I'm just increasing the stability, that's it. Okay, I'm not doing anything much more than that. Coming back here, now you can just calculate this one. Normally, why it is failing, I'm not understanding it, but we will see that. Okay, let me visualize the results. After just visualizing the results, I can see here the stage 1 construction actually. I see that there is a lot of deformation is happening it over here. Okay. What might have happened here? I'm not sure. So let me do one thing. But the site says that this is a crude answer, right? Site says that this is a more comfortable as we have some backend things and all. Okay. Let assume now I realize that after seeing that there is a lot of slope circle I can able to see, which it could not able to be stable, and I am backfilling a soil, and during the backfilling process, one thing I should understand that is like the entire 2 meters of a height I can't build at a time. So now this is where you guys go here, change this also to be a consolidation analysis and to the stage construction, and you say that how many hours you took or how many days you took it to do the stage 1 construction. Now you take that input from the site. Okay, now site people says that it took me for 5 days to construct this particular stage 1. Okay, let's say 5 days and I'm doing the consolidation. Okay, I've just given 5 days and then I'm doing the consolidation. I'm activating this one. Now you start calculating this one. Now you can see the difference in the results too as well. So that's where I will just prove you that. I'll come back to the normal mesh also, and then I'll show you that how the solution works and all. To my knowledge of 99.9%, it should get passed now. Okay, that's where it has been cleared this particular things and all. So in the first is during the construction process, what I considered is like I considered that particular entire whatever the entire block or like a structure of a sand it is there, as I considered it as a plastic calculations, it software assumes that this entire thing is something called as a prefabricated one, and then you are putting at a time onto the soil. That's why as you are putting at a time onto this particular soil, it is failing. As you are putting at a time onto this particular soil, it is failing it. But later on, actually, you understood that this is a construction process it is going on. This is a construction process it is going on, where people took like 5 days to build this particular process, and that's why I could able to solve this particular problem as well. Okay, so that's where I'm telling you that reality, understand the site situation is very, very important when you are doing this. Okay. See, the software in the first case, when you do it as a plastic, it took it as a impact analysis. But the moment when you convert that into a consolidation analysis and you have given a time interval of 5 days, it is going to be take it as a implicit analysis, like slowly level constructions that you are building it. That is what actually during the construction process also you are evaluating the consolidation happening on that. During the construction process also you are evaluating the consolidation process of what that particular thing is. So that's it. But you can question me now, why stage 2 you have taken still it as a plastic calculations? So that means on this particular slope, if that particular slope it is coming it, is it really good? Do you feel that it is impact condition it is working over here fine? No. Even in the case 2 also, as this is a construction process, again you have to consider that as also a consolidation analysis, and then you have to tweak the material properties accordingly, and then you have to choose that. What I mean that you guys are getting me. What happens when I select it as for the stage 1? Forget about the stage 2 right now. For the stage 1, what happens when I select it as a plastic analysis, and what happens when I select it as a consolidation analysis? You're able to understand this or no? Yes, no.
Hello? Yeah.
Yeah, but
Yeah, we got clarified.
okay. See, when you are
Ah,
doing a foundation analysis, you can do the plastic analysis because foundation is a prefabricated one that they are directly taking it up and dumping over there. Or you are putting some structure which is already there, you can just put it over there. But this is during the construction process also you are evaluating it. So that's where. Okay. So
okay.
just consider this concern. Okay. Now, if you see that my stage 2 ka analysis also it got cleared, there is a no problem because of the stability it built over here. It could able to take that particular other set of a load as an impact loading, but whatever the results that you are getting over here is quite different results. Like now you see this. Sorry, not this. I'm showing you the results actually. When you just look into the results, this is where my initial phase. And in the initial phase, I have just building up this. So that's where actually the deformations. Now, see previously plastic analysis is showing a stability slope failure, but now during the consolidation process, actually it is equally coming down, more realistic. This is what we need in the site. Okay. Now, when I go for the consolidation phase of this one, This is how actually perfect. And then actually I went for the second phase. Now in the second phase, see this actually the load it is taken, but actually onto the layer one also, the maximum amount of a load it is falling. Is it really true? Does it make sense? And the maximum deformation is like 0.8 meters. That is 0.7955. You can assume it as 0.8 meters. And it is good or not, that you need to decide it. And if you see this, the consolidations for this, I'm forcing to do the consolidation for 30 days, right? So previously the construction took for 5 days, so that's why 35 days. But when you just come on to this particular stage, it took around like another almost all 25 days, like it took. So 35 days plus another 25 days, that's totally take you around like a 60 days it took to get the consolidate up to reach a minimum pore pressure with a deformation of a 1.2121 meters. 1.121 meters. Let me go for a snip of this. Okay, I've just captured the snip of that. I have it here. Now, make this particular stage also to a consolidation, and you assume that this is also building for another 5 days. Just give okay. Now you can start calculating the results. Into the other YouTube videos also, they might have tell you the procedure how to create a sands, how to create fill filters, how to create a drains, how to build this particular structures and all. Okay, this kind of essence will miss over there. That's why I prefer to come to my classes, look into this, understand the content of it, and then you can do it. Or you can go through my videos too as well in future. See, time taken previously, it was taken around 60 days. This is 60 days. Oh, okay. Now the problem was also solved it exactly. Fine. Now let's see that any difference that we have seen on the days or has the process changed, any change in the deformations. As you already seen that when the first base itself, if it is not now consolidation, it is like you can see the failure. Now you can see it took 64 days for the final consolidation. Previously, it took only 60 days, 60.83, and here it is like 64.04 days. You see the difference? You see the difference? And in this particular cases, I say that it took lesser time because 5 days is a manual construction process itself is going on. So if you 64 minus 5, if you do, it took only 59 days. But whereas in this case, it took almost all 61 days. 2 days of a difference that you can see for the plastic calculations to the consolidation analysis. So this kind of results only will lead you to our wrong decisions into the sites and all. So what you are seeing is correct. What is there in the image is wrong. And here, if you see, it's a 1.121 meters, and the deformations is slowly reduced. Zero point 0.1 meter of deformation it has been reduced it in the small change itself. Now you guys got the importance of understanding during a slope stability analysis or the consolidation process why I have to follow what is happening in the site in the same thing, not only in this, any case of the analysis, what is happening in the site, you have to replicate the same thing over here. You have to follow this. So I hope now you got a better clarity on this. Any doubts up to this? Yes, no. Am I audible, right?
You are audible, sir.
Okay, fine. Then. Thank you.
One more time, we'll have to watch the audio. If there is anything fine details are missing, otherwise
Okay, fine.
the explanation was very good.
Okay, let's go through it and
Best of all
understand it.
sessions.
And if you, yeah, and if you have anything, like we will come, you guys come back to me. Now, I will give you another homework. Maybe in the next class also we can do that. Now select this one, add a phase, and this particular phase we are going to call it as a safety analysis. That's it. Select this, select this particular phase, add a phase, and this particular one that we are going to call it as a sorry safety analysis. Select this one, add phase, and this particular phase again you are going to call this as a safety. And select this the final one, add a one more phase, and this particular phase you are going to call this as a safety. Now you have done all the safety analysis for each and everything. Now calculate it again. Simple. So see, simple structure, how complicated you made now. But for look wise, it's being a complicated. But for deriving this, it took me a very less time. So it's all the safety analysis I'm calculating it for each and every zone. Now, maybe you can do for the stage 2 construction, you take it as a plastic calculations and do the safety analysis, though as it is passing it, see the safety analysis, and again you select the same thing and do the plastic analysis again for consolidation. You can see the difference. You can see the much difference actually. So this is how actually you can see this. Now you can see the slip circle actually. So till now that you might have got it out, I'm doing a slope stability analysis, but you were just showing me the deformations that is 1 meter or 1.1 meter, which is happening. It is happening in the vertical directions only. But how do I identify the slip circle? That's where your safety analysis will give you the slip circle actually. I'll show you that too now as well. The chess game I told you in the beginning of a class, no? Again, it will apply over here also. Understand the site situation, read your site situations multiple times inside your brain, and then come up with a procedure that can be done in the practice or not. So once you sit in front of the practice, it should follow your site procedure automatically. Yeah. Now moving on here. Okay. Now you can see that this is the slope. Step circle, you can see this. Go to the mesh. If you don't want to show the mesh, you can switch off this cluster borders, element contours, geometry. You can switch out the fixities, so you can see a beautiful slip circle over here. Now you guys know how to measure the radius, everything, whatever the distance that you wanted, you can able to measure this. You can just measure the distance from here. That roughly you can take it till here. So that's where you can able to get the distance between this, and that particular distance is nothing but you can call it as your radius over there actually. Okay. So this is how actually you can just go for this. Reports how you can able to use all the things, and this is how you can able to see the slip circle over there. Then you can come back to this result. Yeah. So you guys feeling comfortable with this? So I will take a break over here, and if you have any questions, we can discuss.